Hello everybody, this is John Ross, and I'm here to do a little place value exploration with you as we get to know our base 10 system a little bit better. Our learning objective today is pulled from Standard 4.NSBT.1 from the South Carolina College and Career Readiness Math Standards. And that learning objective reads as, I can understand that in a multi-digit whole number, a digit represents 10 times what the same digit represents in the place to its right. If that seems a little unclear to you at this time, that is okay, because we're going to break things down nicely over the next few slides. Our activator is a real-world problem, and it reads as, two shoppers each bought a different size box of Pokemon cards as shown in the table below. Hank purchased a box that contained 2,000 cards. So we could say that Hank's box has a value of 2,000. Margot purchased a box that contains 200 cards. So we could say that Margot's box has a value of 200. Our question is, based on the data in the table, how could you describe the value of the box of Pokemon cards that Hank bought compared to the value of the box purchased by Margot? And so I know that if I were to take the value of Margot's box, which is 200, and if I were to multiply that value by 10, I would get the same value as the box of Pokemon cards that Hank purchased. And so that tells me a couple different things. One, it tells me that it takes a total of 10 smaller boxes, such as the kind that Margot purchased, 10 of those, to get us the same value as a larger box like Hank purchased. It also tells me that Hank's value is 10 times greater than that of Margot. So it tells me that his box is 10 times greater too. Here, friends, we have some base 10 blocks that we're going to explore. And you have likely used base 10 blocks throughout the years as you have used them to add and subtract. You've also likely used them to represent numbers, whole numbers specifically, and decompose some of those whole numbers as well. The first block that we have here is a unit. Then we have a rod, and we have a flat, and we have a cube. Our question is, what whole number does each base 10 block represent? A unit, that teeny tiny single solitary little block, can be used to represent the whole number 1. A rod, which is a single, the way that it is built, it's built as one long rod, but if we look at it closely, we can tell that it has been built out of 10 of those single solitary little tiny blocks. And so because of that truth, we know that a rod can be used to represent the whole number 10. A flat is built out of a total of 10 rods. And so if a rod has a value of 10, and I have 10 of them, that's kind of like saying 10 times 10. So 10 times 10 gets me 100. So a flat can be used to represent the whole number 100. A cube is built out of 10 flats. So that cube could be used to represent the whole number 1,000, because 10 flats times 100, which is the value of a single flat, equals 1,000. Here, friends, we have a table that we're going to use to compare the values of the various blocks. So for this first row, we have a rod, and we want to compare that rod to a unit. And so I can read this row as a rod is blank times as much as a unit. And so I can recall that a rod is built out of 10 units. And so I know that a rod is 10 times as much as a unit. A flat is built out of 10 of those rods. So a flat can be said to be 10 times as much as a rod. A cube is built out of 10 flats. And so I can say a cube is 10 times as much as a flat. And so one thing that we kind of want to note is that as we move from the right to the left, each block that is bigger and bigger as we move to the left is 10 times greater than the block on the right-hand side. This rod is 10 times the value of this unit. This flat is 10 times the value of this rod. And this cube is 10 times the value of this flat. Now on this page here, we're going to compare the value of the two underlined digits. So we are focusing in specifically on those underlined digits. We need to note the place value of those underlined digits. This 5 is in the tens place. This 5 is in the hundreds place. So this 5 could be said to represent 5 tens, or it could be, if we want to use the base 10 blocks, we could say 5 rods, which of course, whether it's 5 tens or 5 rods, that 5 has a value of 50. And this 5 here is in the hundreds place, and so it could be represented with 5 flats. It could be said to be 5 hundreds. And of course, those 500s have a value of 500. So if I want to compare the value of those two underlined digits, I often can start out with my smaller place, if you will, which this 5 is in the tens and this one is in the hundreds. And I know that if I multiply the value of that 5, which is 50, by 10, I'm going to get a product which is 500. And so 50 times 10 equals 500. So I know that because of that, I know that the 5 in 500 has a value that is 10 times greater than the value of the 5 in 50, because 50 times 10 equals 500. Again, we're going to compare the value of the two underlined digits. We have 7 here, which is underlined, and we have 7 here, which is underlined. These numbers are similar. We've got 2 of the same digits with 7s, right? But then we also have multiple zeros. We can note that the 7s are in different locations. This 7 is in the thousands place. This 7 is in the hundreds place. And so this 7 could be interpreted as 7 cubes, which represents 7,000. And this 7 could be interpreted as 7 flats, which could be interpreted as 7 hundreds. And so I know that if I multiply 700, that is the value of the 7, by 10, the resulting product is the same value as the 7 in this number here. And so because of that, I know that the 7 in 7,000 has a value that is 10 times greater than the value of the 7 in 700, because 700 times 10 equals 7,000. We are again comparing the value of two underlined digits, but instead of having some zeros up in these numbers, we've got 3 and 8, which together, based on their placement, that number is 38. We also have 8 and 5, based on their placement, that is 85. So this 8 here could be said to be 8 units or 8 ones. So this 8 has a value of 8. This 8 is found in the tens place, so it could be said to be 8 rods, 8 tens, or 80. And so I can again note that I am aware that if I multiply 8 by 10, I will get the same value as this 8 here, which is 80. So because of that, I know that the 8 in 85 has a value that is 10 times greater than the value of the 8 in 38 because 8 times 10 equals 80. For our final question, which is structured this way, we're comparing these two numbers, specifically the underlying digits though, 4,736 and 409. Again, I need to note that this 4 is in the thousands place, so it could be interpreted as 4 cubes, which represents 4,000. This 4 is in the hundreds place, so it could be represented with 4 flats, which can be interpreted as 400. And so if I were to multiply 400 by 10, so that's the value of this digit here, 400 times 10, the resulting product would be the same value as the 4 in 4,736. And again, because of that, I know that the 4 in 4,736 has a value that is 10 times greater than the value of the 4 in 409, because 400 times 10 equals 4,000. For our final I do, we have another real-world problem. And so it reads as, a school needs to order glue sticks for the new year. When the secretary looks online at the options the school can choose from, she sees that she can buy glue sticks in the quantities found in the table below. So we have a small box of glue sticks, which contains 10 glue sticks. So we can say that that small box has a value of 10. The medium box has 100 glue sticks. So we could say that the medium box has a value of 100. Our large box has 1,000 glue sticks. So we can say that that large box has a value of 1,000. Our question is, which of the boxes has a value that is 10 times greater than the value of the medium box? So my medium box has a value of 100. If I were to multiply 100 by 10, the resulting product would be 1,000. So the answer to that question is the large box has a value that is 10 times greater than the value of the medium box. And so now, let's see. It is time to move on to our independent practice, which is found in Schoology. So thank you for joining me, and I'll see you next time.